Greetings everybody, I am Nishant representing Sri Chaitanya Techno School, Harmau, Bangalore. The name of my project is Selene. The members of Project Selene include Nishant S, Anushka Umrani, Navneeta R. Krishnan, Manish Reddy A, Kaushik Reddy T and Akshita R. Sheth. Before we get started, I would like to thank the school management, NASA and NSS, National Space Society, for hosting this wonderful event, wherein young minds like me and my fellow mates get to present their ideas.
So, the question arises, why Project Selene? First of all, we have a unique location, better mineral detection technology, ice structure. We intend to preserve the lunar culture by the use of indigenous materials, better modes of transportation, better modes of communication, improvised agricultural sector, production of helium-3 and helium-4, implementation of a better form of government and civilian protection department, a double-layered central hub and superior waste management system.
Here we have Project Selene's submission videos agenda. Location of Project Selene and its advantages. Project Selene will be located in the lunar frozen orbit, having an inclination of about 86 degrees and would be located 7 kilometers above the lunar regolith. Among the many locations we have found out to be beneficial, 86 degree inclination and 7 kilometers above the lunar regolith has proven to be more advantageous from our point of view. Advantages of our location. Due to our location, we would be facing zero perturbation, relatively less launch speed of our spacecrafts, thermal ejection crisis is minute, and simulation of gravity is much easier. Significance of the name. The name Selene is the Greek personification of the moon. You can ask why the name. As previously discussed, our settlement would be located in the lunar frozen orbit. In order to pay our tribute to the moon, we have named our project as Selene. The construction sequence. Step 1. Construction of both the lunar bases of the settlement. Step 2. Inflatable molds of the central hub and the docking port would be constructed. Step 3. Spokes of the settlement would be constructed. Step 4. Molds of all the different tori's of a settlement would be attached. Step 5. The isohex, clamp-like structures of settlement would be constructed, which would hold the whole settlement together. Structure of Project Selene. Selene would be a 3-tori structure which would consist of 2 residential tori, 1 industrial tori, 1 central hub, 1 docking port, and the isohex. Rotating and non-rotating structures. Rotating structures of the settlement include all the different tori of the settlement, and the non-rotating structures of the settlement include the central hub and the docking port. Classification of rotating and non-rotating structures is important, as rotating structures consume energy whereas non-rotating structures do not. Here we have the pencil sketch of Project Selene's structure. Dimensions of the different structures of Project Selene. Layers of Project Selene's inflatable molds. The first layer of Project Selene's inflatable molds would be the DuPont Teflon. Second layer would be 1 micron silver. Third layer would be 1 micron inconel alloy. Fourth layer would be 5 microns of polybenzoxazole. And the fifth layer would be ice at minus 20 degrees Celsius. Here we have the unique features of Selene. These topics would be explained in the further slides. The ILCT scheme. Goals. To decrease the dependence on planet Earth for materials, to be more of an autonomous body, to provide superiority to the lunar culture by using indigenous materials for construction. How exactly? Here's how. The amount of materials exported from Earth for construction of the settlement would be decreased, as imports from Mars would cost way less than those from Earth due to their proximities from the settlement. The settlement's spacecrafts would be largely made of lunar materials with about 20:1 bootstrapping advantage. Glass composites, also known as GLACs, from the lunar materials, helium-3 production facilities, indigenous lunar fuels like regolith itself, helium-3, liquid oxygen and powdered aluminium with liquid oxygen.
carefully designed and cost-efficient methods of transporting passengers from Earth to the settlement. Fuels made of indigenous material making them cost-efficient, manufacturing of robots from indigenous materials and alloys like aluminium. The intensity of practice of aeroponics and hydroponics will decrease to half, and importance would be given to agriculture based on lunar regolith, replacing complex methods of mineral detection with Project Selene's mineral detection techniques, which incorporate the use of neutrinos. The bounty of advantageous byproducts produced in the production of helium 3 include 6,100 tons of fuel, 3,300 tons of water, helium 4, and many more. I would conclude by saying there are plenty of resources and Selene can pave its way to prosperity with them. Lunar culture is beautiful and offers complete support for the establishment of a civilization. Agriculture. Agriculture in Selene can be classified broadly into two types. One, using hydroponics and aeroponics using lunar regolith. Agriculture using lunar regolith. The nutrient solution should contain nutrients in perfect and fixed proportion. Constant temperature of 67 to 72 degrees must be maintained. If the temperature is exceeded, the produce will literally die. Medium in which plants would be grown include rockwool, perlite, and vermilite. These mediums would be porous, which would prove to be beneficial as the nutrient solution could reach the roots. Paper. In today's world, paper has its own significance. Till date, they are being used as record of land they own, and many other important documents are being recorded using paper. The 6 members of the group ourselves, being a little bit more bibliophiles than Kindleophiles, believe that paper must exist today and forever, but we do not intend to cut trees for the purpose of paper. We do agree that most of the records would be recorded digitally. However, in order to provide exposure to the young minds from the digitalized form of education by providing at least textbooks to all age groups. Addressing this issue, we came up with the possibilities of using two kinds of artificial and indigenous paper in the settlement, which would not require cutting of trees. Chemical means of paper production. This process would require neither calendaring nor bio-orientation, and the paper obtained would possess the characteristics similar to cellulose paper with additional better physical properties: impermeability to moisture and air, resistance to synthetic oils and greases, and dimensional stability using differing atmospheric conditions. The paper would be produced by homogenization of the following substances in a conventional rotatory mixture. 1. A particular class of strong polyphenols for the stiffness and framework of paper. 2. A polymer incompatible with polyphenols chosen from homopolymers or copolymers containing a predominant amount of styrene for hardness and tearability. 3. A macromolecular material with a compatibility between the above two substances and containing at least one homopolymer of ethylene, propylene, or butylene, and at least one homopolymer of isobutylene, butadiene, or isoprene, or even butyl rubber. Mineral paper. Production of mineral paper would be simple. They would be made of calcium carbonate and a little amount of resin. Characteristics of this paper include they would be tear resistant, water resistant, and wrinkle proof. Self-replicating system. Sectors such as the nuclear arm, lunar mining of radioactive elements, and heavy metal processing industries in the central hub pose some risk for human employment. Given the dangers associated with human workforce in these sectors, the production and manufacturing facilities in these sectors would need to be automated as much as possible. The facilities would be flexible, easily controlled, automated, reprogrammable, and multi-product, and would require little human efforts. So, why do we actually need self-replicating system? It would greatly enhance the organization of large-scale industries in Selene. The system would reduce the dependence of terrestrial resources, thus helping in achieving one of the important goals of space settlement. Increased output capacity could be accomplished, which would ensure high income due to productivity, superior processing, and manufacturing. Moon Transport Vehicle. The Moon Transport Vehicle is a cylindrical structure which would be used by the officials of the lunar base as a mode of commutation to move between the lunar base and the lunar surface. It would consist only of one structure, which will be the cylinder. As we humans have not discovered every nook and corner of the moon, we believe that we would have to construct tunnels for the movement of the MTVs. The MTVs would have 4 light ion thrusters which could be used for giving a little upthrust to the structure and would have refillable parachutes so that in case of any malfunction, the impact of the damage is reduced. By staying true to the ILCT scheme, we believe that the moon transport vehicle would be made only of indigenous materials. Illuminating system. As the name specifies, the illuminating system would be used to illuminate the settlement. So the layers of the illuminating system of Selene are as follows. First layer, Selene Smart Glass. Second layer, Selene Aerogel. Third layer, lighting. Fourth layer, Selene Aerogel again. Fifth layer, Selene Smart Glass. Bicameral omnipotent box, aka BOB. BOBs are special machines to enter the Martian atmosphere and extract carbon dioxide from its atmosphere and trade neutrinos with the Martian facilities. So, the functions: collection of carbon dioxide, liquefaction of the collected carbon dioxide, storage of carbon dioxide and neutrinos, execution of the programmed missions, and providing live footage. Features of BOBs include abundant capacity for storage, liquefaction to increase the storage of carbon dioxide, 6 in number, 3 being sent at a time, efficient and calamity resistant design, constant monitoring and communication with the control system at Selene, strong materials. Materials used in the construction of BOBs include aluminium, which would be used for the body of the box, graphene, which would be used for the inner coating of the box, as epoxy fiberglass, which would be used as the camera lens, and stainless steel as the pressure regulators. Antimatter. Antimatter is matter with opposite charge. It could be used to produce energy. Challenges faced. To produce energy, antimatter would have to come in contact with matter. However, annihilation will take place in this process. With the current researches, determining the essential conditions for production of antimatter is not possible. However, we believe that antimatter would give us 100% efficiency and maximum results. So how do you think we plan on storing it? Well, here's how. It would be trapped within the magnetic fields present between the two layer central hub. As mentioned earlier, the two layer central hub would be used in the storage of antimatter. This would be a future project as the current status of development in antimatter is very less, but we do believe that in future antimatter will make its own mark in the society. Here we have the getting there strategy. The first step in the getting there strategy would be transporting the residents from planet Earth to the low Earth orbit. The second step in the getting there strategy is called the escort ferry. Well, the escort ferry is a large spacecraft that would run on fuels made of indigenous materials. So the role of the escort ferry would be to engulf the spacecraft sent from planet Earth, and last but not the least step in the getting there strategy would be the flight of fame. The residents would be shifted from the low Earth orbit to the settlement's docking port. Life support. The topics enlisted below would be explained in the further slides. Gravity cannot be produced, however, it can be simulated. Methods in which gravity can be simulated are magnetism, linear acceleration, and rotation. We have opted for rotation as a method to simulate gravity. Rotations per minute in the residential tori would be 1.7 approximately, and the rotations per minute in industrial tori would be 1.3 approximately. Oxygen. The methods in which oxygen will be produced in Project Selene are as follows. FeTiO3 plus H2 gives rise to TiO2 plus Fe and H2O. As a result of the reduction, water from the product's side would be either used to meet the basic needs of residents in its original form or be electrolyzed to give breathable oxygen. Note: the utilization of water in its original form or as electrolyzed oxygen would purely depend upon the necessity to be met at the particular point of time. H2O gives rise to H2 plus half O2. Temperature of 700 to 100 degrees Celsius is required for this process, and the sustainable conditions would be provided accordingly in the settlements, laboratories, and oxygen production units. The hydrogen produced with the oxygen at the product side would be precisely recycled. Oxygen would constitute about 10.4% of the product. Water. The methods in which water would be produced in Selene are as follows. The Sabatier system. CO2 plus 4H2 gives rise to CH4 plus 2H2O. The heat required to start the reaction is 165.0 kJ per mole. The methane obtained here would be used in the production of graphene or replenishment of carbon and hydrogen, or as a fuel. It would be flexible. Nickel would be used as a catalyst in this reaction. Second method, reduction of ilmenite with hydrogen. FeTiO3 plus H2 gives rise to TiO3 plus Fe and H2O. As in oxygen production, the lunar poles and the debris clouds. Abundant amount of water in the form of ice have been found in the permanently shadowed areas of the lunar poles. This water could be easily extracted and would be used in the initial phase of the settlement. The debris clouds around the moon have been found to contain water vapor. Actually, replenishing this water could be easy, as the lunar atmosphere would freeze the water back into ice at the poles. Cracking of Martian carbon dioxide and combining the produced oxygen with hydrogen to produce water. Reduction of lunar gases. And in the above enlisted ways, we believe that the water shortage crisis will be eradicated in Selene. Food. The food provided to the residents will be sent through a variety of quality checks. In order to provide the non-vegetarians their mouth-watering delicacies, we decided to undergo the method of cloning. So, what is cloning? Cloning is a biological process of producing similar population of genetically identical living organisms. Clones are exact genetic copies of one another. Medicine and healthcare. Features of medicine and healthcare in Project Selene. Sophisticated healthcare systems and equipment, advanced doctors and robots, use of nanotechnology to replicate various tissues. Every sector that is about 200 meters would have a small healthcare infirmary. Every section that is about 550 meters would have a big hospital. Every citizen would have fitness and metabolism trackers attached. A slight variation observed in the fitness tracker and metabolism tracker would send alerts to the sectors and section. Energy. Energy can neither be created nor destroyed. It can only be transferred from form to form. The major forms of energy with respect to Project Selene, that is most commonly in use for its functioning, are solar energy, nuclear energy, electrical energy, and thermal energy. Each of these forms of energy would have their own applications, and these applications would ease man's life in Project Selene. Transportation divided into two types, namely internal transportation and external transportation. Coming to internal transportation, can be further divided into two types: inter-toroid transportation and intra-toroid transportation. So let's start with inter-toroid transportation. It can be divided into two further types: public transport, which would incorporate the use of gyroscopic transportation, and the second type would be self-commutation, in which preference would be given to other modes of commutation which would use pretty much less energy or no energy. We have Intra-torride transportation, which would use the principle of electromag levitation to transport people from any part of the settlement to another. External transportation. This mode of transportation would be used for discovering the vast cosmos, tourism, trade, and many more. This would be accomplished by the use of indigenous fuels and other exported fuels as well to increase productivity. As mentioned earlier, Project Selene would be located in the lunar frozen orbit, because of which thermal ejection would be minute. Thermal ejection would be done using the simple chemistry concept called effusion, the movement of gas molecules through a small orifice. Care will be taken that the effusion ducts would have diameters which will be smaller than the molecule's free path. There would be diffusion ducts around the surface of the settlement. During this process, there will exist no air in the artificial atmosphere and hence the presence of a small vacuum. For how much ever time it takes, the residents would be indoors as every enclosed structure would have its own oxygen supply. Radiation shielding. To overcome the radiation dose, radiation shielding is necessary for the settlement. In radiation shielding, the materials which would be used should have low densities, high Young modulus and tensile strength, low thermal conductivity, high melting and boiling points, and mainly do not produce secondary radiation. Materials in Selene's radiation shielding would be titanium, tantalum, niobium, magnesium alloy, aluminium, foam, and carbine. Lunar base. Selene would have two lunar bases, which one of them would be located in the Shackleton crater in the south. The coordinates of the Shackleton crater are 89.9 degrees south, 0.0 degrees east. Depth of the Shackleton crater would be 4.2 kilometers and diameter of Shackleton crater is 21.0 kilometers. In the northern hemisphere, the lunar base will be located in the Peary crater, and the coordinates of the Peary crater are 88.63 degrees north, 24.4 degrees east. Its depth is unknown. The diameter is said to be about 79 kilometers. Construction would take place using majority of indigenous materials. Sectors of the lunar base and dimension. The lunar base would have four different sectors, which would be the habitation sector, observatory sector, docking sector, and lunar mining sector. The habitation sector can be further divided into habitation sector 1 and habitation sector 2. And the dimensions of the lunar bases located in the northern and the southern hemisphere would be height about 200 meters, which would be 656 feet, diameter about 500 meters, which would be 1600 feet, length, which would be 2 kilometers, about 1.2 miles. Sources of income for Project Selene would be tourism, lunar mining, exchange of indigenous goods with other settlements and colonies, last but not least, trading. Robots. As we think about the future, the picture which flashes in our mind would be robots, to be specific, humanoid robots. Certain strategies and precise characteristics based on which the robots would be built to provide maximum efficiency are cognition, skills based on their location and function. Robots would need to know how to handle the expectations and needs of the people. They must be cost efficient, self-replicating. So, the types of robots in Project Selene would be Edubots, Lunobots, Healbots, and Selenobots. Industries: nuclear industry, pharmaceutical industry, automobile industry, textile industry, and heavy metal processing industry. All these industries will be working in their own autonomous ways to provide for mankind. Nuclear industry, pharmaceutical industry, automobile industry, and the textile industry would be located in the industrial torride, whereas the heavy metal processing industry would be located in the central hub. Evacuation. Why this issue? Colonizing a foreign environment would require us to have a backup strategy ready in case of any damage to the settlement. It is always better to stay on the safer side. Thus, evacuation strategy is necessary. Major causes of evacuation.
solar flares, explosion in the residential and industrial tori, unpredictable damage. For rapid evacuation, we have about 6 evacuation docks in each of the residential tori and about 4 evacuation docks in the industrial tori. These evacuation docks would have evacuation pods in them that would have the ability to seat about 160 inhabitants, including 150 residents and 10 crew members. These evacuation pods would have food, water, and other essential life supports that is sufficient for 160 members on board for about 5 days. The total estimated cost of Selene would be around 202.10 billion USD. The project would be initiated in the year 2051. However, the construction would begin only in the year 2059 and would be terminated by the year 2091. Total time taken for the construction would be about 40 years. Thank you for going through this video presentation.